politician up here, right? Sure, I'll answer your questions. Ask me a question, then I'll give my pre-planned speech somewhat related to your question. So let's do number 5, and then we'll see like how it relates to number 7. So natural log of x and y. So this is the same as log base e of x. No one would write it that way, but it wouldn't be wrong to write it that way if that helps. I want the argument to equal the base, and I want the argument to equal 1, because those are easy points to handle. So the base is e, means I want the argument to be e. So if x is e, then the argument equals base. And then I have natural log of e, or log base e of e. What's that equal to? 1. That's why we picked the argument to equal the base, so we get an easy answer. If the argument is 1, then x should be 1, and the natural log of 1 is 0. The log of 1, whatever the base, the log of 1 is 0. So I got 2 easy points to deal with here. E is 2.7, so when I go to the graph, 2.7-ish as best I can, comma 1, and 1, comma 0. And that's only 2 points, so that's like, that's not a whole lot going on. But I also know that the argument has to be greater than 0. So that sort of sets up, not sort of, it does set up a boundary, an asymptote. And so with those 2 points plus an asymptote, I feel pretty good about what my graph looks like. Question?
Is there an asymptote on the ones on the sheet too?
There is, but we don't usually talk about it because it's not. It's easier. It's more important for the graphs of the logs to know what the asymptote is. Okay. So yes, there is an asymptote on the exponents.
Don't write it in on the test.
You do not have to draw it in on the test. There could be questions about it, but you don't have to draw it in. Number 7. So again, now there's 2 ways to go. Once we have the parent function, we can either use parent function ideas to graph this one, or we can go back to argument equals base, argument equals 1. I'll do it both ways because I don't know which way you prefer. So if we want the argument to equal the base, then I need my argument to be e. The natural log of e is 1, but then there's a negative out front. If I want my argument to equal 1, then x should be 1. And the natural log of 1 is 0. And negative 0 is still just 0. So e negative 1 and 1, 0. And my asymptote didn't go anywhere because that's just looking at the argument. So there's my picture for number 7, using the argument equals base, argument equals 1 method. But many of you know the parent function transformations really well, and so you know that a minus sign out front, what does that do to the graph?
Y side.
It's a y flip, so that's across the x-axis, so be careful how you phrase it, but it's an up and down flip. A y flip. And so that alone means you could just look at this graph and flip it over, or you could, if I'm thinking about these ordered pairs, how do I apply a y flip to my ordered pairs or to this table of values? What would I do to get, if I didn't have this table already there, what could I do to the parent function table to get a new table? Change the sign of the y's. So I could start with this table, make both of those negative, and get this table. So there's a bunch of different ways to get to this graph. Questions on graphs of logs? Let's do an exponent graph, and then we've done a bunch of exponent graphs. So flip back to worksheet 2. And let's see. We just did an E problem, so let's do number 1, a 3 problem. And then we'll do either 2 or 3, either one. Looks like I started this because we always want our exponent to be -1, 0, and 1. So my parent function, my x will just be -1, 0, and 1. 3 to the -1/3 is 1/3. 3 to the 0 is 1. 3 to the first is 3. Plot my points. There is an asymptote. We don't talk about it much on these, but there is an asymptote there at y equals 0. And so there's my parent function. Let's see. Let's do number 4. Yeah, because that has an x in the other spot compared to the 2 we just did. So x and y, I want my exponent to be -1, 0, and 1. So if I want my exponent to be -1, then x needs to be +1. 0 wouldn't change anything. And if I want my exponent to be +1, I want x to be -1. That way -1 becomes +1. So 3 to the -1 is 1/3. 3 to the -0 is 1. And 3 to the -1 is 3. So we plot those points, and sure enough, it looks like something's been flipped around. That was the sort of the exponent way. The parent function method would say a negative up there with x. What does that do to the graph? It's a y-axis flip, or it flips it in the x direction, or a left-right flip. And so we compare 1 and 4, and we got a left-right flip. If we want to, go ahead.
And 3 was a negative, it would be an up and down flip.
Correct.
Okay, I'm confused by the -1 with like the 3 and the 1 is with the 1/3. Like, does that change?
Because if I put in x equals 1, then I have 3 to the -1 because of that minus sign.
Yeah, okay, yes. Thank you.
You're welcome. So back to this flip thing. If I want to flip left and right, that would mean change the left-right variable is the x variable. So sure enough, if I take my x variables and change their sign, I get those x variables. And that's one way to do it. So there's 2 ways to do all of these. The parent function way, or sort of back to the original way with the table of values. All right, I feel pretty good about what's on the test now, because I wanted you to see, again, there's 3 graphs of each. There's a graph of an exponent, there's a parent function, and then 2, well, I guess, child functions. I don't know what the right word is, because you got the parent and then you got the kids. So there's 1 parent and 2 kids for exponents, and then there's 1 parent and 2 kids for logs.
Did you go over just like really quickly, just like a log one? I went over like easy.
So like 1 through 4?
Yeah, just like one of those.
Okay.
Doesn't have to be, or just like the first one.
Let's do, is the parent one enough, or do you want to do one that has a twist in it there?
Because that's just moving it left or right, up and down.
You're right, yeah. So if you're comfortable with transformations, then we can do number 1.
Yeah.
And you know that this one's just going to be left 3.
Mm-hmm.
So you would take the x values and subtract 3.
Yeah.
Okay, then back to the parent function. X and Y. Let's see, for logs, the two easiest logs, maybe the only two easy logs, are when the argument is the base and when the argument is 1. That's the only, not the only two, the two easiest logs to figure out. So if the base is 2, then I'll make the argument 2. And what's log base 2 of 2? 1. If I make the argument 1, what's the log base anything of 1? 0. So 2, 1, and 1, 0. And man, that's especially confusing, maybe misleading, because like it's only 2 points. Where do I draw the graph? Except that I also know that the argument has to be greater than 0. So there's an asymptote or a wall at 0. And I know what the shape of logs look like, just generally speaking. So something like that for the parent function. And then you could flip or move or whatever you needed to do after that.
And are there ever going to be like any stretching or compressing on the test?
No. In theory, you know how to do them,
Yeah.
right? If there's a 2 out front, you need to multiply these by 2.
Mm-hmm.
But no,
Okay.
we won't stretch or compress. Anything else? Especially worksheet 3. We did 1 graph. Oh, we did 2 of the 5. So, the property questions. Although, I would do the graphs first, because if you have the graphs, then answering the property questions should be easy. Charlotte?
Just on the worksheet 1, if the exponent is 0, it's just going to be 1, right?
Correct.
So like on number 3, the y would just like not be there.
Yeah, it's kind of like not even there, because y to the 0 is just 1. So this would be x to the 6th, z squared. I just threw out y to the 0, not because it's gone, but because it's equal to 1. X to the 7th, z to the negative 6. So this is a simple one that tests a lot of stuff. So I'll end up with an x in the bottom. This is good because we hadn't done one of these today. How many z's am I going to have, and where are they going to end up?
4 at the top? No, 8 at the top.
8 in the top, right? Because that negative 6 will move to the top, and then I'll have a total of 8 of them up there. And so that would be A. Good?
Did you do number 7 on worksheet 1?
Sure. Number 7, worksheet 1, negative 2/3. Yuck. When there's so many steps, you have multiple ways to get there. So I think I would clean up the insides first as best I can, and then stick the negative 2/3 on there. So I can't do anything with the 27 over 125. But x's would be end up with 12 in the top and y cubed in the top. And then negative 2/3. So basically everybody gets the negative 2/3. It's just so this looks annoying to write it out this way. And maybe you're to a point where you wouldn't need to do this for all of them, but just to make sure we know what's going on. You could do that. You could handle them separately. So the question was, can I take the negative, flip everybody, and then do the 2/3? Absolutely, you can. I arguably should do that first anyway. Let's see, 27 to the negative 2/3. I'm running out of space, so I know I'm going to flip it. I want the cube root of 27, and then I want to square the cube root of 27. So cube root of 27 is 3, squared is 9, but also put it in the bottom. That's probably way too many steps to be skipping like that. Maybe not. Same thing with 125. The cube root squared flipped.
So 5 to 25.
Yep. So 5 squared is 25, and then where does it go?
On top.
In the top. So already I'm feeling pretty good about A and B. Let's see. X to the, well, 2/3 of 12 is 8. 24 divided by 3 is 8. Negative means flip it over. So x to the 8 in the bottom. 2/3 of 3 is 2, but negative is in the bottom.
Could you write out how you found it for extra?
I did 12 times negative 2/3. And I can either reduce first and get negative 8, or I can multiply and then divide and get negative 8. So multiplying fractions. And yes, that'll be the part that gets some people on the test. They know all the new rules, but they forgot how to multiply fractions. Nobody in here, of course, though.